Hello friends, welcome back to C#.NET online training video series. Today I'm going to discuss how to use abstract classes and abstract method in our C# real-time application development. This is part 3 of abstract class and abstract methods. Please watch previous two videos where we discussed what are exactly abstract classes and abstract methods and the rules and regulations that we can apply or that can be applied to abstract classes and abstract methods, as well as we have also discussed in our previous video all the important interview questions related to abstract class and abstract methods. So today I'm going to show you how to use abstract classes and abstract methods in your application development. So before proceeding, let us first discuss what are exactly abstract classes and abstract methods. In simple definition or in single statement, you can say that, or we can say that a method without a body is known as abstract method, and a class that contains any abstract methods in it is known as abstract class. That means abstract, if a class contains any abstract method, then you need to declare that class as abstract class. And if you are creating a method without its implementation, then that method is said to be an abstract method, right? A class that is declared by using the keyword abstract is called an abstract class. An abstract class is a partially implemented class. Partially implemented class means what? Partially implemented class means some of the methods are implemented, which is going to be same for all the next levels of classes, and some of the method are unimplemented. The next levels of classes is going to provide implementation for those methods. So it's a partial class means it's a partially implemented class means it contains both concrete method means method with implementation, and abstract method means method without implementation. Along with this, the partial class also contains variables, properties, constructors, anything you can declare. Even though you can declare static members, you can declare static methods, you can declare also static constructor inside a abstract class, right? Now come to our main topic, today's topic, how to use abstract classes and abstract methods in C# application development. We have already discussed how to use inheritance in our one of our previous video, right? We already discussed how to use inheritance in our application development, right? If you have not watched that video, then I strongly recommend you to watch that video where we discuss how to use inheritance in real-time application development. What we discussed that application development is all about dealing with entities, right? Whenever we are creating a application, that application deals with a number of entities, right? For example, if you are taking an application of school, right, then the entities which are associated with the school application might be your teacher, might be your student, teaching staff, non-teaching staff, temporary staff, right? All these things are nothing but entities which are dealing with your school application, and every entity is also having a set of attributes, right? And then what we need to do, we need to identify the common attributes that are associated with each attributes, and we need to put them in an hierarchical order. So exactly the same thing we'll try to understand now with abstract classes and abstract methods, right? What we discussed with the inheritance, the same thing we are going to discuss with abstract classes and abstract method, because we are using abstract classes means we are going to use inheritance, right? Without inheritance, there is no use of abstract classes. Why? Because you cannot create an instance of abstract class. If you cannot create an instance of abstract class, then all the abstract member or non-static method, whatever you declared in your abstract class, are no use. Abstract class means the child class is going to be used to provide implementation to the abstract methods, and using the child class object only, you can consume the abstract methods as well as non-abstract method of the abstract class, right? The concept of abstract class, the concept of abstract methods and abstract classes are an extension to the inheritance, where in inheritance we have been discussing that with the help of a parent class, we can provide property to the child classes that can be consumed by the child classes, which gives of reusability, right? So what it means? It means if we are going with the inheritance concept, then in inheritance we have a parent class. That parent class having some properties and some data member, some member function, and we can reuse those parent class properties under the child class, right? And that is not nothing but the concept of reusability. Along with the parent providing property to the children, the parent class can also impose some restriction on the children with the help of abstract method, right? So the same thing is also applicable. If you are declaring an abstract class, it is going to be do the same thing. That means in abstract class also we can provide some properties, or we can also define some method in the abstract classes that are going to be consumed by the child classes, but with some restriction. What restriction? Now the restriction is the abstract class provides some abstract method, and the abstract class telling to the child classes, hey Mr. Child class, you want to consume my non-abstract methods, you want to consume my properties, you want to consume my no, static on all these things. Yes, if you want to consume, then first of all you need to provide implementation to the abstract methods what I am declaring in my class. Once you provide implementation to the abstract method, then you can consume the non-abstract method of my class. This is the restriction, or this is the rules that we need to follow while working with abstract classes and abstract methods, right? Now let us understand one real-time example or one use cases of abstract class and abstract methods. Right. Suppose we are going to develop an application for calculating the area of a rectangle, area of a circle, area of a triangle, and area of cone. Currently, we have four different types of shapes, and we need to calculate the area of all these shapes. So for our application, what are the entities? The entities are going to be rectangle, circle, triangle, and a cone. Next, once you identify the entities, next what we need to do? We need to identify the attributes that are associated with each entity, right? So if you look at this rectangle, then what are the attributes we require to calculate the area? Height and width. For circle, we need radius and pi. For a triangle, the attribute might be width and height. That width is also called as base. And if you want to calculate the area of a cone, then what are the attributes required? Radius, height, and pi, right? So these are the attributes that are required to calculate the area of a rectangle, circle, triangle, and a cone, right? So these are the attributes, and so these are the entities, four entities, and their corresponding attribute. Next, we need to identify the common attributes. Why do we need to identify the common attribute? Is because we need to put the common attribute. If we put, see, why we are going to identify the common attributes? If we are not identifying the common attribute, then what problem we will face? What problem we will face means we will put the each attribute in everywhere, right? Each attribute in everywhere means we have code duplication. The same attribute we are going to define in four classes, three classes, right? That means if you are defining the same attribute in each classes, means it's code duplication, right? It's not code reusability, and we are using object-oriented programming, right? And the main objective of object-oriented programming is code reusability, not code duplication, right? So this is the reason why we need to identify the common attribute, right? See, today we are developing the application to calculate the area of four shapes. Tomorrow it might be possible that some new shapes comes into the picture, like polygon, square, rhombus, etc., right? So the common attribute in our case, in our example, height, width, radius, and pi may be used in all those shapes as well, right? So what common attribute we are identifying now? It might be possible that tomorrow, if we are going to add some new or some different shapes, right? They might be used these common attributes, na? So this is the reason why we need to identify the common attribute, right? Once you identify the common attribute, then what we need to do? What we need to do is first we need to define one class. Let's say we define one class called shape with all those common attributes, right? Then your class would be like this. So you have to define one class called shape, and in this sub, what I'm declaring the common attribute height, width, radius, and I'm taking this const as a float pi, right? Now, if I make this class shape as parent class, then for rest of the four classes, that is rectangle, circle, triangle, and cone, then we do not need to declare the above attributes in those classes, right? Already we have declared those attributes in the shape class. Then I can directly inherit our four classes from the shape class and directly consume these four members, right? So we can directly use them. For example, you can see So here rectangle class inherit from shape class means all those members are available in the rectangle class. Circle class inherit from shape class. That means all these four data member what we define in the shape class are also available, right? Same in the case of a triangle and a cone, right? So what we need to do, we need to identify the common attribute. We need to put all the common attribute in the parent class, and then we need to make our child class inherit from the parent class. So we do not need to or do not require to redefine this member again and again inside the child classes, right? So we have done this much, right? This is nothing but what you can say reusability feature which is provided by the inheritance concept. Next, what we are going to do is we are going to create public constructor in each class and initialize the required attribute. Why we are going to create public constructor? It means this parent class having four properties, right? One constant and three, you can say class variables, right? And all these three variables are not required in all the classes, right? So what we need to do, we need to create a public constructor, and whatever the data member required for calculating the area of that particular class, only those member we need to initialize, right? You can see this rectangle class for calculating the area, what we need? We need height and width, right? So what we need to do? We need to create one public constructor which is taking two parameter, and that public constructor is going to initialize height and width, which you can see in this case height and width. Radius is not required, right? So you can see radius is not taking as a parameter to this rectangle class. And for calculating the area of a circle, we only require a radius and pi. Pi is already declared as a constant, no need to reinitialize. So this circle class taking the radius parameter only. It is not taking height and width. So we are just initializing this radius parameter. Then triangle class, right? For calculating the area of a triangle, we need height and width. So what I'm doing, we are just taking height and width as a parameter. We are not taking radius as a parameter, and we are just initializing this whatever value we are passing. With that value, we are just initializing the class variable height and width, right? Then the same concept is also applicable here. To calculate the area of a cone, what we required radius and width. So I'm taking radius and height as parameter and initializing the class variable, right? So this is how we need to initialize the required parameter for each and every classes, right? Now, our requirement is to find the area of each shape. That is, we need to find the area of a rectangle, we need to find the area of a circle, we need to find the area of a triangle, we need to find the area of a cone, right? Then the question is where we need to define that method. Whether we need to define that method in each of these classes, or whether I need to define that method inside my shape class. Where exactly I need to define that method, right? So this is the important point that we need to understand. We cannot define that area method inside our shape class. In our shape class, we cannot define that area method. Whenever I'm saying define that area method, means method with implementation, method definition. We cannot provide method definition inside the shape class. Generally, what comes to the parent class means the things which are common to the child classes. Which are common to the child classes, that we need to put inside the parent class. Right now, we want a method. Now we want a method that should return the area to the appropriate shape, right? So if we are taking the area of a rectangle means it should give me the area of a rectangle. If I'm taking area of a circle means it should give me the area of a circle, right? So the point that you need to remember, we cannot define that area method inside the circle, inside the shape class. The reason is the formula to calculate the area varies from shape to shape. The formula for calculating the area of a rectangle is not same as the calculating the area of a circle. It's not same for calculating the area of a triangle, right? The formula is going to be vary from shape to shape. Because the formula varies from shape to shape, so we cannot define that method inside the parent class. If the formula is same for calculating the area, then we can define that method inside the parent class. But here the formula is going to vary. So you cannot put that method definition inside the parent class. So this is the place where exactly abstract class and abstract method come into the picture. So what you need to do is we need to define that get area method as an abstract method inside the shape class. And as we define that method as an abstract method, then it is mandatory to make the class as an abstract. So you can see the method we are declaring with the abstract keyword, and once this method you declared using the abstract means it's become an abstract method. And as your class contains one abstract method, then it is mandatory to declare the class as abstract as well. Now you can see this get area method is declared as an abstract method, right? Now, and we have already seen this same class is implemented by or inherited by all the classes, right? Rectangle class inherited from shape, triangle class inherited from shape. So what it means? It means the child classes, the four child classes, now they have to provide implementation for this get area method. Now it is the responsibility of the child classes to provide implementation for this get area method. Now you can see this rectangle class inherited from the shape class. This is our public constructor, which is basically used to initialize the data member. And here we are overriding this method. So you need to override the or you need to implement this abstract method by using the override modifier that we have already discussed, right? So here you can write the logic to calculate the area of a rectangle. So here I'm writing y into height and returning that this will return me the area of a rectangle. And here I'm writing the logic to calculate the area of circle. How? Pi r square, pi into radius, right? So this is how you can write the logic to calculate the area of a circle. And here I'm writing the logic to calculate the area of a triangle, height into width divided by 2. And this is how you can write the logic to calculate the area of a cone. So now all the respective four classes have implemented the method in their own way, right? Now the implementation is going to be changed. The implementation is varies from child classes to child classes. So this is the process of how we are going to use abstract classes and abstract method in our application development using C# language. Now you might have one question, sir. Why I'm going to declare this method, right? Even I can directly implement that method here, na? Without using override keyword, I can directly implement this method. Without writing this public abstract double get area, I can directly provide method definition inside the rectangle class, inside the circle class, triangle class, and a cone method. So what is the big deal? What are the advantages we are getting if we are providing implementation via abstract method, right? This is the important question, and that we need to understand. Why do we declare the get area method in the parent class and implement it under the child classes? Why we cannot directly define the get area method in the child classes? Yes, you can do this. But by declaring the get area method in the subclass, we have one advantage. What is that advantage? The advantage is that the method name is going to be same in all the four classes. The method name is going to be same for all the four classes, right? To make you understand what I'm going to do, I'm just copy pasting the code to my application, and this is the same example what we have discussed, right? This is my abstract base class, right? This is my rectangle class, circle class, triangle class, and cone class. So what is the advantages means the method name is going to be same for all the four classes. You can see this is the get area method name, and here the method area name is same. Here the method name is same, right? Here the method name is same. Here the method name is same. Not only the method name is same, but also the method signature is also same. Signature means the name of the method and the number of the parameter the method is taking. Here you can say the name of the method is get area without parameter, get area without parameter, get area without parameter. So this is the advantages of using now. So suppose if you are not using this method, then what is the problem? Suppose you are not using this get area method, right? Then suppose this class is developed by developer one. Okay, developer one is working. So it is not. It is possible that for a single project, multiple developers are working. This rectangle class implementation given to developer one, right? This class implementation given to developer two. This class implementation given to developer three. This class implementation given to developer four, right? Now the developer one working on this project, right? Then if you are not providing this get area method implementation, then he no need to override that method, right? Then what he can write? Simply he can write get area rectangle, right? Developer two working on this method, a different developer, he provide the method name as get area as it is, right? And this is developer he, so what he is providing, so he giving the name as calculate area, right? And here the method name what he is providing is providing the method name as area, simply area. That means all the method name are going to be changed or not. Yes, this is the problem we are going to face. So what is the problem? The problem is, suppose you are creating an instance of this class, then you need to confuse. First of all, you need to know what is the name of the method. So you need to check the get area rectangle, right? So this is the problem you will face. That means each method implementation is going to be different. Method name is going to be different. Some of the method might take some parameter, right? You cannot control this. Tomorrow new classes tomorrow new steps come into the picture. Then what should be the name of the method? A new developer, a new method name. There is no such standard, right? To make all these things possible, provide some same feelings to all the user of the shape classes. So what we need to do? We need to define this one, right? We need to define this one. So what we need to do? We need to, sorry. So what we need to do? We need to define that method in the rectangle in the set class, abstract class now. Now, if you try to change the method signature, then you will get an error. What error you are getting? You are getting rectangle, no suitable method found to override, right? And if you go rectangle class doesn't implement the inherited method, get area. So you cannot change the method signature, right? The method signature is going to be same, right? So this is the advantages of using. For example, if four different people work on the project and if four different people work on a different shape, then there is no guarantee that all the developer is going to provide the same name and same signature for the method. The advantage of declaring method in shape class is that the name and signature are not going to vary in all the four classes. Now, this is the complete code what we have discussed so far. This is our shape abstract class having the common properties and the abstract get area method. This is the constructor, and using this constructor we can initialize only those parameters which are required for rectangle class. Right, for rectangle class you can see this height, height is required, width is required. So we are taking two parameters for the constructor and we are initializing these two class variables, right? And then we are having this version of the implementation. This get area method is going to return the area of a rectangle, right? Then the same thing for circle, what is required? For calculating the circle, we only require radius. So this parameter, this constructor setting the radius parameter, right? And then we are writing the logic to calculate the area of the circlet, right? For triangle, what we required? We required height and width, right? Height and width. So we are taking two parameter, storing the values inside this class variable height and width, then writing the logic to calculate the area. And the same thing in the case of a con also. Now, from the program class, what we can do, we can create an instance of rectangle and get area method, right? Create an instance of triangle, get area method, create an instance of con, and we can call the get area method. So this is how you can use abstract classes and abstract method in your application development using C# language, right? Now you might be one question, sir. Previously you told us the abstract classes biggest advantage is that it can have both abstract method and non-abstract method. But in this case, we do not find any abstract method or any non-abstract method. Instead of this, I can use inheritance. Yes, you can use inheritance, right? For this example, what we achieve using abstract class, you can also achieve the same thing using inheritance. Let me give you another example where you will see the real use of this abstraction, right? So what we are going to do, we need to calculate the electricity bill for domestic and commercial plant. So for that, what I'm doing, I'm creating one abstract class called plant. And in this class, I'm having one protected method, protected get area method, get rate method. And this get method, get rate method, as it is protected, that means this method is only available to the child class, right? As it is the abstract method, you can see this commercial plan is a child class of this plan class. And as it is a abstract method, he needs to provide implementation to this get rate method. And he is implementing this protected get rate method, right? For commercial plan, we are returning the rate as 5. And for domestic, it is again implementing this plan abstract class and providing implementation to this get rate method. Here you need to observe this protected. As you making this class method as protected, as you are making this get rate method as protected, so we already discussed in our access specifier section or in our access specifier video that we have different types of members, 6 different types of access specifier you can use. And once you make the member as protected, it is available within the class as well as to the derived classes. You cannot access those member from the non-derived classes, right? So this getRate method is going to be implemented by the child classes. Now second part, and here we have written the calculation method, right? Here we have written the calculation method. This is a public method, and this method taking some number of units, right? Suppose you are passing 250, and then it will call the getRate method. And what is the rate? Suppose you are calling this method on this commercial plan object, right? Then this getRate method will return you 5. And if you are calling this method on a domestic plan object, then this getRate method will return you 2.5, right? And once you rate, then it will show you the bill amount per unit is rate into units, right? So this is how you can implement. Now come to this plan P. So this is nothing but your abstract class plan. So we are creating a variable of your abstract class. That is possible, but the instance is going to be the child class. See, you can see the P new commercial plan. So now we are creating an instance of this commercial plan. And when we call this calculate method on this commercial plan instance, so this version is going to be executed. And once this version is executed, then it is internally going to call the getRate method. And this getRate method is defined in the child class, right? And inside which from which child class this method is going to be executed, on which object you are calling the commercial calculation method. You are calling the method on the commercial plan object. So this version of the getRate method is going to be executed. And when you reassign that with the domestic plan, and when you call that calculation method, then in this case, the same method is going to be executed from the plan class, but for getRate, it is going to execute from the domestic plan method, right? Now, if you run the application, then you will see the output. So the output, you can see the application is running. Still it's running. Yeah, we got the output. Bill amount for 250 units is 1250, right? Why? Because for commercial plan, the unit rate is 5. 5 into 250 means 1250. And for domestic plan, 150 units, and the rate is 2.5. So it is going to return you 375. So this is another use case or another real-time scenario where you can use abstract class and abstract method. That's it for today. Thank you for watching this video.